Hello everyone. Uh, Today we'll discuss the problem based on the cantilever beam, and we'll draw the shear force diagram and bending moment diagram of this cantilever beam having this 2-point load and one couple in this beam. So this is the cantilever beam having this point load 10 kilonewton and then the 5 kilonewton. Then there is one couple from here to this couple. The distance is suppose 3 meter, it's 2 meter, and then from here to here this 2 meter. So I'm giving name this A, this point is B, this point is C point, and here it is D point. So this is the problem related to the cantilever beam having 2-point load on a span with one couple. So how to solve this problem? Simply, to solve the problem, first we draw the free body diagram as we have discussed in an earlier lecture. So if you draw the free body diagram, so this is the free body diagram since it is cantilever beam, and this is the fixed end. So here the reaction RD will come, then the horizontal reaction RDX will come, and the moment will come to counterbalance this force. So moment I'm giving name this MR. So this is the 10 kilonewton, this point A, and this is the point B where the 5 kilonewton is there, force, then couple is there, and this couple is this 5 kilonewton meter. Couple is 5 kilonewton meter. So this is the 5 kilonewton meter couple is there. This is the point C and this is the point D. So this is the free body diagram of this problem, and then the next step is equation of equilibrium to find out the support reaction. So we use this equation of equilibrium to find out the support reaction. So first calculate the summation of fx equal to 0. So here only rdx is there, that is nothing but equal to 0 because no other horizontal force is there. Then similarly the summation of fy equal to 0, so only the vertical force will consider. So summation of fy equal to 0. So here as per our assumptions that if you move from right to left, I move from right to left this side, if our movement is like this, so downward force will consider the positive, so positive 10 kilonewton will be there. Similarly this positive 5 will be there, and then because this is the summation of y, only the vertical forces we will consider, no moment will consider here. So this 5 kilonewton meter is nothing but a couple, it's nothing but a moment, so we will not consider this as a vertical force. So this plus 5 and this plus 10, so this is the downward force we are taking positive, and here RD is there, only vertical force which is upward, so we are taking this RD as a negative and equal to 0. So RD we can write this 15 kilonewton. So RD value is 15 kilonewton. So now to find out this moment value, we can also take moment equal to 0. So moment about D we can take. So here when we are talking the moment, when we are taking the moment, this clockwise we are taking positive, anti-clockwise we are taking negative. So moment is nothing but the force into perpendicular distance. So 10, moment is clockwise, so 10 into the total distance, which is nothing but here to here 3 meter, here to here 2 meter, and here to here again 2 meters. So total is 7 meters. So 10 into 7, this clockwise positive, then 5 clockwise into 3 and 2 5 meter, and here in this cantilever beam, since the counter this rotation is there which support this beam to go downward, because these vertical forces try to bend this beam downward side, so this counter this moment will try to resist it, so that because its moment is anti-clockwise, so we are taking here minus mr equal to 0 because moment is there. So this mr will be, so if you calculate this, so 70 plus 25, okay, one couple is also there, that is a 5 kilonewton couple is there having this clockwise rotation, so couple will be considered here in this moment, so plus 5 will be there, so that plus 5 is nothing but the couple, so here the plus 5 is there, so mr will be 70, 25 plus 30 is nothing but 100 kilonewton. So this is the moment value. Because one couple was there, it was missed, so we have taken this couple as a plus 5 because the clockwise moment is there. So this is the 5 plus 5 minus mr. Now how to calculate the shear force diagram calculation. To calculate the shear force diagram, this particular problem, so here at A we can see that at particular A the shear force diagram only take the vertical forces, because shear force is nothing but summation of all the vertical forces. So at A here we can see that 10 kilonewton is there, so at A shear force is 10 kilonewton, that I can write this is nothing but shear force, or at A shear force is 10 kilonewton, we can write like this. The next at B, here you can see that from A to B, because no other force is there, so only the 10 kilonewton is constant up to B, and at particular B 5 Newton is there. So just before, we can say that just before B it's a 10 kilonewton only, and at B the shear force is, since because it's a downward, for the shear force downward we are taking as a positive, so the 10 is positive and plus 5 is also there, so that will be 15 kilonewton. So at B here it's a 15 kilonewton, and at A it's a 0, at A it's a 10 kilonewton, not 0, and at C, just before C, if you see just before C, shear force is here, the C is there, C point is there, so whatever the value is there, that is 15 kilonewton, will be constant up to just before the C, and at C because this 5 kilonewton moment is there, but since it is a shear force diagram, so moment will not be considered, only the vertical forces will consider, so this will be constant just before C, and after C also it will be constant. So this is the 15 kilonewton, and at C the shear force will be 15 kilonewton, because only we are taking in the shear force diagram the vertical forces, we are not taking the moment, we are not considering the moment while calculation the shear force diagram. This is very important. Now at D shear force will be, because here A, when we are moving A to B it's a 10, then B it becomes a 15, and it's constantly moving because no other vertical forces is there up to RD, up to D. So only the 15 will be there, which is positive because downward, and at B RD is there, at D RD is there, which is upward. So RD we can write here 15 minus RD value is nothing but 15 kilonewton here. This is the 15 kilonewton. So we can write an upward force is there, so direction is negative and equal to 0. So at D the shear force will be 0. Now based on that we can draw the shear force diagram. So here I can draw the shear force diagram. This is the positive shear force and this is the negative shear force. This is the X. Now we can, based on this calculation, 8A, it's a 10, so I am just giving name 8A. This is the A, 10 kilonewton, which is positive. So I am just putting the, because it's a point load, so vertical line will be there. So this is nothing but 10 kilonewton. And then at B it's 15 kilonewton. Now at B, this is the B. So because no other forces will be there, so just before B it's a 10 kilonewton constant will be there, but at B it's another 5 kilonewton is there, means total 15 kilonewton is there at B. Now at C, this is the point C, is going constant. Here also it's 15 kilonewton is there, and just before D also it's a 15 kilonewton, and at D it's 0. So at D here equal to 0. So this is at D. At A it's a 10 kilonewton because of this point load, so vertical line will be there. Then A to B there is a no force, so constant 10 kilonewton will be there. Then at B it's a 15 kilonewton positive, so it will go positive 15 kilonewton top. Then the C point, only the couple is there, which we are not considering to draw the shear force diagram, only the vertical force we consider. So here constant line will be there, this total constant line will be there just before the D, it's a 15 kilonewton, and at D again it comes back to 0. So this is the shear force diagram for this particular problem, positive shear force diagram. This is the shear force diagram. Now next is the bending moment diagram calculation. So this is the diagram to calculate the bending moment. Now we calculate bending moment at A. The bending moment is here at A, this point. Bending moment will be 0 because the bending moment is nothing but force into perpendicular distance. Here distance is 0 because x equal to 0. We start right to left, we move from right to left. So here and here is particular, this x is equal to L. So at A bending moment will be 0. At B bending moment at here at this point it's nothing but force into perpendicular distance, this 10, because here this force try to bend this beam downward side, so it will be, the beam will be like this, which is nothing but hogging right to left. So this is the negative, and we are taking right to left downward movement, this we are taking as a negative. So this is minus 10 into 2, it's nothing but minus 20 kilonewton. Just this is at B, and then just before C, bending moment will be, because when we move here to here, these two forces and distance will be taken up to this or just before C. Then at C we'll take this couple. So just before C, this minus 10 into 4, this minus 10 into 4, then minus 5 into 2, so nothing but this minus 50 kilonewton. This minus sign only shows the direction, that is an upward bending moment or downward side bending moment. Magnitude will be remain same, just this negative or positive will show only the sign. and then at particular C the bending moment will be minus 10 into 4 minus 5 into 2 minus 5. This is nothing but a couple which we are taking here, that is 5 kilonewton meter, and it try to bend downward this beam, so negative sign we are taking, and this is nothing but 55 kilonewton. So this is 55 kilonewton at C, and then just before D, this minus 10 into total distance is 3, 5 and 7, total is 7 meter, minus 5 into 5 meter, then minus 5 just before D, means up to just before D. What will be the bending moment diagram? We can calculate the value from here, and it is nothing but minus 100 kilonewton, and at D, this is the bending moment. At D, bending moment will be minus 10 into 7 minus 5 into 5 minus 5 plus this MR will be there. This moment we try to rotate beam upward side, so we are taking positive, and the value of this MR is nothing but 100 kilonewton, minus 55 5 plus 100 kilonewton, that is nothing but 0. If you put the value this total will be 0. So here from this calculation we can draw this bending moment diagram. At D the bending moment will be 0, just before D it will be minus 100 kilonewton, at C it is minus 55 kilonewton, just before C it is minus 50 kilonewton, and at B it is minus 20 kilonewton, and at A bending moment will be 0. So based on that we can draw this bending moment diagram. So before that I draw this shear force, which already we have discussed. This is the point A, this is point particular B, this is C point, this is D point. This is the shear force diagram. Value is 10 kilonewton. Shear force diagram 15 kilonewton. This is 15 kilonewton, then it is 0. So this is positive shear force diagram. Now we draw this bending moment diagram for this particular problem. So at A the bending moment is 0, this is 0 kilonewton, and then at B, so value at B is minus 20 kilonewton, so this is the minus 20 kilonewton. Then at C it is minus 50 kilonewton, so at C we are drawing this minus 50 kilonewton. Then at particular C, just before C it was minus 50 kilonewton, and at particular C it is minus 55 kilonewton. Then just before D it is minus 100 kilonewton, and then at D it is 0. So this is D point, this is C point, this is B point, this is A point. So because the point load, so the bending moment diagram will be inclined, and this is the diagram, and then it becomes here 0. So this is the bending moment diagram for this particular problem, and it is a negative shows it's a hogging, means downward side it will go because of the upward forces which apply onto this beam. This is the bending moment diagram. This is bending moment diagram for this particular problem. This is shear force diagram, and this is bending moment diagram. Thank you.